As we begin the plant layout demonstration, notice that the startup screen provides quick access to tutorials, recent files, tips, and web links. Solid Edge contains a complete list of translators, including popular DXF and DWG translators. The preview window shows exactly how the file looks in AutoCAD. This interface also supports color 7 in AutoCAD, which changes from black to white depending on the background color setting. We can even pan and zoom around the drawing in the preview window. Solid Edge is the industry's best in translating AutoCAD data. Full control over layers is also provided. We can show or hide any of the layers as defined in AutoCAD, and the preview quickly shows the results. The translation wizard also gives us full control over the file units as well as the target drawing sheet size. While Solid Edge will select the ideal size, we can always make adjustments. Solid Edge also maps AutoCAD lines to an appropriate Solid Edge line type, so we'll have exactly the same lines after the import. The same level of intelligence is carried through with colors as well, even for color 7, so we can continue to work on a black background, but have black lines automatically change to white. To get an idea of the intelligence of Solid Edge's import capabilities, let's quickly simulate an AutoCAD look and feel by changing the background color to black. Notice how all the lines read as color 7 automatically invert from black to white. Notice how the integrity of the AutoCAD file was maintained in the translation to Solid Edge. Even the layers were maintained, and Solid Edge's Layers tab in the Edge bar makes managing these layers quite easy. We can control their visibility, we can add, rename, and remove layers as needed, and just like in AutoCAD, we can set the active layer. A common task in AutoCAD is to reuse data using blocks. Solid Edge has improved on that concept by allowing us to store blocks in a single file that better organizes our library and lets us share them faster. We can build up our libraries as we go, storing the block data in specific files on central servers. To make us more productive, Solid Edge ships with many of the most common blocks for electrical, piping, and mechanical use. The blocks are organized in easy-to-follow folders and library files. Blocks are added with a simple drag and drop approach, and as we drag the block around, notice that the preview is in a different color to better highlight what and where we are placing it. Blocks can be dropped anywhere on the drawing, or can be placed with precision by snapping to the graphic key points such as endpoints, midpoints, centers, or aligned with any of these key points. The block attachment point to the cursor can be set during the creation of the block. Once complete, the actual block displays with appropriate color, hatching, line style, and so forth. We can add as many blocks as we need, but in many cases it's faster and easier to pattern the existing data. During the patterning operation, notice the handy preview that shows us where the instances will be placed, and notice how it updates the changes to the instance count or spacing. In this case, we're using a standard fixed pattern. However, Solid Edge can also compute a pattern to fill a designated area by finding the optimal instance count or adjusting the instance spacing. Most recently used values are maintained for future use. On this side, we only need half as many blocks, so we'll make that value from 12 to 6. Blocks simplified 2D drawing design, but Solid Edge's implementation makes their use even more productive. In some cases, we may need to rotate a block, and with a simple hotkey, we can rotate blocks easily. When adding the turnabout, the power of Solid Edge shines. Notice that we're using the key points of different components to correctly position this block. The dashed alignment indicators assist us in this process. As we finish up placing the last block for the 1.6 meter conveyor, notice the sheet tabs at the bottom of the drawing. Currently we're working on a 2D model sheet. This sheet is at 1:1 scale and mimics working in AutoCAD. If you're used to drawing geometry in full scale, you can still use that same approach in Solid Edge. While blocks are a productive way to go from nothing to something, Solid Edge also includes the most common drawing tools for lines, arcs, circles, and here we'll draw a rectangle with a simple drag approach to create a new size conveyor section. Smart dimensions can be added to lines, arcs, circles, and placed anywhere on the drawing. Dimensions can be added and adjusted to set the ideal size. Now that the main layout is complete, we're going to show off a little bit and add some completely drawn robots. Notice the detail of these components. While we could have drawn this from scratch, any drawing view from a 3D model can be converted to a block. This process takes data reuse to another level, as we can create sophisticated blocks directly from our 3D models. Within the past few minutes, we imported a 2D AutoCAD floor plan and added a manufacturing line using predefined blocks and developed some new components with standard drawing commands. Some key tools in Solid Edge included the industry's best AutoCAD import translator, complete display control over layers, colors, block libraries, and alignment and snapping for precision placement. Many of these tools and workflows are available in 3D that let you take plant, equipment, layout, and design to the next level.